Good day, students. Welcome to part 4 of the Algebra I CST review. In this installment, we're going to be going over questions 51 through 60. Okay, so let's go ahead and take a look at question number 51. So question 51, it's a word problem. It says a volleyball court is shaped like a rectangle. It has a width of x meters and a length of 2x meters. Which expression gives the area of the court in square meters? So when given a verbal description of a geometric object, it's always good to make a sketch of the object and then label it so it can help us set up an equation that can resolve the problem, right? So we're looking for the area here of the rectangular court. So let's make a sketch, okay? We're dealing with a rectangle. Um, it was the rectangle of the court, of the volleyball court. This is question 51. So this is the width and this is the length. All right, we're informed that the width is x meters. Okay, so this is x meters and the length is 2x. All right, so what represents the area of a rectangle? We know the formula for the area of a rectangle is given by length times width. All right, so we substitute 2x for the length and x for the width. The area of this court is going to be given by 2x multiplied by x. Okay? Alright, so how do we do this? It's simply going to be 2 using the product property of exponents. X times x is simply x squared, right? Because you can assume there's a 1 here and there's a 1 there, and when you add those two ones, you have 2x squared, representing the area of your court. Okay? So it's going to be 2x squared square meters. Alright, so we can clearly see that the answer for 51 is option letter B. Alright, let's move on to 52. For question 52, it says, what is the perimeter of the figure shown below, which is not drawn to scale? So let's figure out what the definition of perimeter is first. What is the perimeter? Perimeter is basically the distance around the figure, right? So we're looking for the distance around this entire figure. So if we add up the measures of all the sides, that should help us determine what the perimeter is. Okay, so let's go ahead and do that. The top is x plus 13. The left side right here is 3x plus 2. Okay, let's add those two together. This gives us 4x plus 15. And then on the bottom, we have x plus 5. And then we also have 2 and 8. We can add 2 and 8, that's 10. Okay? Let's add all that together. We're going to have 4x plus x. There's 1 here. 4x plus 1x is 5x. Plus 15 times plus 5 is 20 plus 10 is 30. Alright, so we have 5x plus 30. And the last side, on the right side here, is 3x. So we add 3x over here. Notice how I lined them up by degrees, right? Like degrees occupy the same column, so we can add downwards without making error with like terms, okay? Combining unlike terms. So this becomes 8x plus 30. So answer for option 52 is C. Okay, just by simply adding all the measures of each side together, that will give us what the perimeter is. So this is what the perimeter is. All right. Now let's take a look at question number 52. Remember, you can find the copy of this document on mathserve.com/test prep. All right, let's take a look at 53. It says, what is the factored form of 3a squared minus 24ab plus 4b squared? Plus 48b squared. All right, so the first question is there a greatest common factor for all three terms? Well, I don't know. How about we break it down and see, okay? So I'm going to break down the first term is 3 times a minus, if I break down 24, let's use the factor tree. This is even, so I can take out 2 times 12. This is even, I can take out another 2 times 6. This is even take another 2 times 3. So basically 24 can be decomposed into 2 times 2 times 2. 3 2s are 3. And then we have the A and the B. Okay? All right, now let's decompose 48. 48, I can take out a 2. 2 goes into 48 since it's even 24. And then we already know what 24 is, right? It's 2 times 2 times 2 times 3. So we can use that here. So plus, let's do that on the side here. So it's just double 48, so it's 2 times 24, which is 2 times 2 times 2 times 3, which is what we determined here, and then times v times b. All right, now that we have it broken down completely or decomposed, now what can I factor from all three terms? What is common? I notice this has a 3, this has a 3, this has a 3. So guess what? I can factor out a 3 from all three terms, all right? So let's go ahead and do that. If I factor out a 3, outside I'll be left with a squared minus, let's take this, what we factored out, cancel it so I can put it back in. 2 times 2 times 2 is 8ab plus 2 times 2 times 2 times 2. 2 times 2 is 4 times 4 is 16 plus 16b squared. Okay? All right. Now what we're going to do next is factor this term using the x game. Okay? All right. So to do that, remember we're going to use AC. It's also called the x game is also called the AC method. All right. So what I want to do is I want to write this term in the parentheses, this trinomial. I want to write it as a term with an expression with 4 terms, so I can factor by grouping. Okay. So AC goes on top, B goes on the bottom. AC, there's a 1 here. 1, put a 1 there. Since there's nothing, there's always 1 is a coefficient if there's no number in front of a variable. So AC is 16, and then B is negative 8. So what two numbers multiply to give you 16 and add to give you negative 8? How about negative 4 and negative 4? Those two work, right? So I'm going to rewrite this problem as 3 times A squared minus 4AB minus 4AB plus 16B squared. Okay? Now I'm going to factor it down the center and factor by grouping, all right? So break it down the center, and let's break it down term by term. So we're going to have 3 times A times A minus 4 can be written as 2 times A times B minus 4 can be written as 2 times A times B plus, if we break 16 down, let's do that on the side here. Take out 2 times 8, 2 times 4, and then 2 times 2. So it's 4 2's, right? So 1, 2, 3, 4, and then B times B. All right, so let's factor by grouping. From the first two, I can take out A, okay? So that's going to yield 3 times, let's use bracket, 3 times A times, you're left with A minus 2 times 2 is 4, and then there's B right here, okay? And now let's shift to the right side. We'll bring down a minus. And we can take out, in this side, I can take out, what can I factor out? I can factor out 2 2's, and I can also factor out a B, okay? So if we do that, if I take out 2 2's, that's a 4, right? And if I take out a B, that's a B. So I'm going to be left with A. Now, anytime you factor out a minus from a plus, the sign changes to a negative, because minus times minus is plus. 2 times 2 is 4, and then you have a B, okay? And then when we put this together, we have 3. Now, the two terms that are common, this term right here, and this term, we can factor them out into 1, which is A minus 4B. And the term left on the outside, A and negative 4B, we can put together as A minus 4B. Okay, A minus 4B. So our answer is going to be option C. 3 times A minus 4B times A minus 4B. So answer option C is your correct answer. All right, let's move on to question number 54. If we are to factor, again, it says which is a factor of that. So for 54, we're going to factor x squared minus 11x plus 24. I'm going to use the x method again, although there are different ways that you can do this. I like the x method for factoring because it's very consistent with factorable quadratic trinomials, all right? So I'm going to have AC on the top and B on the bottom. There's no coefficient for the x squared, so we'll put a 1, okay, just like we did in problem 53. All right, so let's see. AC is 1 times 24, which is 24, and B is negative 11. So what two numbers multiply to give you 24 and add to give you negative 11? I have no idea, so what are we going to do? How about we make a list of factors? Okay, I'm going to make a list of factors of 24, and um, I'm going to organize them in pairs that yields 24 as a product, and then see which combination I can add or subtract to give you negative 11. All right, so let's write down 24 on the top, and we're going to be pairing up factors and then see how we can get 11. All right, so I know 1 times 24 is 24. This doesn't work because when I add it, I get 25. When I subtract, I get 23. How about 2 times 12? That doesn't work either because when I add it, I get 14. When I subtract, I get 10. 3 times 8, when I add it, I get 11. Oh, that actually works. So 3 and 8 is a good combination. All right, so let's do that here. So we're going to have x squared. How do we do the signs? We want to keep both of them negative, right? Minus 3 minus 8 is negative 11. So minus 3x minus 8x plus 24. All right, so break it down in center. And we're going to factor by grouping just like we did in problem 54. So here, 53, sorry. So here we have x times x minus 3 times x. And then we can break 8 into 2 times 2 times 2 times x. And then if you remember what we did with 24 in the other problem is 2 times 2 times 2 times 3. All right, now for the first two terms, we're going to take out x and an x. So take out x. So we have x minus 3. And then on the right side, we're going to take out 1, 2, 3 2's. So minus 2, 2, 2 is 8. 2 times 2 times 2 is 8. And you're left with x. Now, anytime you factor on a minus, this sign changes into a negative 3. Okay? This sign changes to a negative, so you have the 3 there, bring it down. All right, let's finish this off. These two terms that are common, we're going to factor them out into one term, x minus 3. And what are you left with? You're left with x minus 8. Okay? So let's see. Which of these show up here? We have x minus 3. So our answer is clearly option B. Okay, let's move on to number 55. Number 55, we're asked to factor completely. I'm going to show you two methods of factoring this problem. I'll show you the long way, and then I'll show you the short way. Okay? This is a perfect square trinomial. That's why we can do it in two different ways, all right? So let me do it the long way using the AC method of factoring, and then I'll show you the shortcut. Okay? So let's call this method 1. Method 1. All right, method 1 is the AC method. AC. So we have 9t squared plus 12t plus 4. There aren't any common factors here because if you look at the options, none of them have a common factor factored out, so we don't need to bother breaking it down. So I'm going to head right into my x game. I want to find two numbers that multiply to give me AC and add to give me B. All right, so in this problem, AC is 36. AC is, this is A, B, C. AC is 36 and B is 12. All right. So what two numbers multiply to give you 36 and add to give you 12? This one isn't difficult. Remember 6 times 6? That works perfectly. So we're going to have 9t squared plus 6t plus 6t plus 4. Okay? Now we're going to break this down. and factor by grouping, okay? So before we factor by grouping, I want to partition my center so I can know how to do it. All right, so now we have, for the first two, I can break down 9 into 3 times t, and I can break down 6 into 2 times 3 times t, and then over here I can break 6 into 2 times 3 times t, and then break 4 into 2 times 2, okay? So for the first two terms, I can take out 1 3 and 1 t, okay? So I factor that out, 3t, and I'm going to be left with 3t plus 2. And on the right side, bring down this plus, I can take out a 2, just 1 2, okay? So that yields 2 times 3t plus 2. Anytime you do your AC method factorization correctly, these two quantities in the parentheses are always the same. Okay, that's an easy way to check. So you notice that this and this are the same, so I can factor that out. So we have 3t plus 2. And what am I left with? I'm left with the terms on the outside, 3t and positive 2. So this becomes 3t plus 2. All right? Since both factors are identical, you can express them as a square. So this is basically 3t plus 2 quantity square. And the answer is option A. Okay? All right. Now, what we're going to do, I'm going to show you a different method of doing this, okay? This method is just for only perfect square trinomials. So, method 2, it doesn't work for any uh, trinomial, only perfect square trinomial. So perfect square shortcut is a shortcut, okay? All right, so how do you know that a quadratic trinomial is a perfect square trinomial? That's a question. Now this is how you do the check. Let me write out the problem. The problem is 9t squared plus 12t plus 4. How do I know? If I root the first and the last term, if I take the square root of the first and the last, and I double it, do I get the middle term? Do I get the center? That's the question. So if 2 times the square root of the first and the last equal the center, then it is in fact a perfect square trinomial. Okay? So let's do that and see. So this is going to be 2 times 9t squared is 3t. Square root of 4 is 2. 2 times 3 is 6 times 2 is 12, 12t. So guess what? This is equal to the middle term. So this is a perfect square trinomial. This is one way you can check. So if it passes this test, double the root of the first and the last equal the middle, then you can do this factoring trick. You just simply root the first term and the last term, bring down the middle sign, and that will give you your factored form. So it's going to be square root of 9t squared, the square root of 9 is 3, the square root of t squared is t, bring down the plus, the square root of 4 is 2, group them into a parenthesis, square, end of story, answer is option A, okay? So this shortcut works only for perfect square trinomials. All right, let's move on to the next question, question 56. We asked to factor 332 minus 8z squared. So first thing we're going to do, let's decompose this completely. 32, let's use factor tree to break down 32. 32 is 2 times 16. And 16, 2 goes into 16 8 times, and then 2 goes into 8 4 times, and then 2 goes into 4 2 times. So it's 2 to the 5th power. So 32 is, actually, let's write it as 2 times 2 times 2 times 2 times 2, 5 2's. And then 8, you notice 8 here is 3 2's, so 8 is 2 times 2 times 2 times z. All right? So why did I do this? Well, I want to extract the GCF if there is any. All right? So there's a 2 here, 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 there's a 2 here. Okay? All right, so take out 3 2's, that's an 8, times 2 times 2 is 4, minus z times z is z squared. Okay? Now to factor this binomial here, you notice this is a square because 2 times 2 is 4 and this is a square. So we're going to use a factoring formula for difference of squares, which basically says if you have a square minus another square, the factored form is their sum and difference of their roots. So you root the first and the last, you add and subtract your square roots. Okay? So in this case, I'm going to take the square root of 4 and the square root of z squared, and I'm going to add and subtract your square roots. Okay, so we're going to have 8 times 2 minus z times 2 plus z. And there goes your final answer. So for 56, our answer is option B. All right, let's move on to the next question. Question number 57. Uh, so for 57, it says, so for 57, all right, it says 57, x squared is added to x. The sum is 42. Which of the following could be the value of x? So we have x squared, added means plus, to x. And the sum is, the word is basically means equals, right? So is means equals 42. So which of these could be the value of x? Now the quickest way we can do this problem is by plugging in the answers into x and see which one works. Okay, so let's start out by testing option A. If option A doesn't work, then we move on to option B, okay? So does A satisfy this equation? In other words, if I plug in A for the x's, do I get a true statement? All right, let's see. X squared, I'm going to say for option A, let x equals what? Negative 7. All right, x is now negative 7. So let's plug into the original equation. Is negative 7 squared plus negative 7, is it equal to 42? Is it? That's the question. Okay. So negative 7 squared is 49 minus 7. Is 49 minus 7 equal to 42? 49 minus 7 is 42. Is 42 equal to 42? Absolutely. So this checks out. So since option A checks out, our final answer is option A. Had it been that option A did not check out, we'll just simply move on to B, C, D, and hopefully one of them is correct. All right, let's move on to the next question, question number 58. It says, what quantity should be added to both sides of this equation to complete the square? Okay, all right. All right, so for 58, to complete the square, let's write it down. To complete the square, you add negative b over 2. Actually, just b over 2. b over 2 is sufficient. The sign doesn't really matter. So you add b over 2 squared. Okay? b over 2 squared is what you use to complete the square. All right? So don't forget that. That's really important. So we have x squared minus 8x equals 5. Now, what on earth is b in this problem? You know that a is 1, because there's a 1 right here. There's no number, you put 1. This is a, and this is b. So to complete the square, we're going to need b over 2 squared. So what is b? b is 8. What are we going to do with 8? We're going to divide it by 2, which equals 4. And we're going to square it, because we have to do b over 2 squared. So 4 squared is 4 times 4, which is 16. So the question says, what should I add to both sides to complete the square? Guess what? 16 is what you add to both sides to complete the square. On the left side, you have a perfect square trinomial, which you can solve by taking the square root. Okay? So the answer to number 58 is option C. All right, let's move on to 59. It says, what are the solutions to the quadratic equation? Now, there are different ways you can solve a quadratic equation. Factoring, completing the square, or using the quadratic formula. You can also graph. But if you notice that the answers here are integers, so that means this is not a prime quadratic. We can actually factor it, all right? So x squared plus 6x equals 16. So I'm going to solve this one completely, okay? Another way you can do this is by plugging and chugging. You plug in answers and see which one you use a true statement. That's one way of doing it. But I'm actually going to solve the entire problem, all right? Okay, so to solve this, first thing to do when you're solving a quadratic equation is you want to put it in standard form. Now, what is the standard form for a quadratic equation? We have you have all the terms in descending order and it's set equal to 0. Okay, you have 0 on one side and all the terms in descending order. This is almost in standard form. The only problem is this constant is on the wrong side. We need to move the constant to the left side, all right? So to put this in standard form, we subtract 16 from both sides. And then we're going to have x squared plus 6x minus 16 equals 0. Okay? Now to solve this, I'm going to factor and then use the zero product property to finish it up. All right, so let's go ahead and factor. I'm going to make the x game. Use the AC method. So a is 1 here because there's no number in front of the x squared, so put a 1 here. So AC is going to be negative 16, and b is going to be 6. So what two numbers multiply to give you negative 16 and add to give you 6? Okay, let's write our pairs that yield 16 and see which combination adds to give you 6. All right, so 16, 1 times 16. This doesn't work because it adds to 17 and subtracts to give you 15. 2 times 8. If you add these two, you get 10. If you subtract them, you get 6. So actually, this works. This is nice. So what we're going to do here, we're going to have 2 and 8. But we need a difference. The small number has to be negative in order for the difference to be positive, okay? So that's what we can use to factor this. So we're going to have x squared minus 2x plus 8x minus 16 equals 0. Break it down to center and factor by grouping, okay? So from the first two, we're going to have x times x minus 2 times x plus, break down the 8. 8 is 2 times 2 times 2 times x. And then 16 is 2 times 2 times 2 times 2. You can do that using your factor tree, okay, to decompose your composite numbers. All right, so factor out an x on the left side here. Take out an x. And you're left with x minus 2. And on the right side, if you always bring down the sign, this is a plus. That means no sign change will happen. So we take out 2, 2, 2, 2, 2, 2. That's 8. And then you're left with x minus 2 equals 0. All right, further we're going to have x minus 2 times x plus 8 equals 0. Now to finish this off, we're going to use a zero product property, all right? So you set each factor to 0, and then you solve, all right? So on the left, you add 2 to both sides. You have x equals 2. And on the right, you minus 8 from both sides. And you have x equals negative 8. All right, so the answer is x equals 2 and negative 8, which is option C. All right, so there you have it. Okay, so now let's go ahead and take a look at the last problem, question number 60. So in question 60, it says, Leon correctly solved the equation x squared plus 4x equals 6 by completing the square. Which equation is part of her solution? So this is like the previous problem we did in 58, but we actually have to do one more step, okay? So x squared plus 4x equals 6. So how do we complete the square again? Remember, the formula for completing the square is b over 2 squared, okay? In this case, a is 1, b is 4. Okay, so b equals 4. What do? We divide it by 2 and square it so that we can complete the square. So divide b by 2. 4 divided by 2 is 2. And when we square that, b over 2 squared is 4. Alright, so that's what we do. We're going to add 4 to both sides to complete the square. So we have x squared plus 4x plus 4 equals 6 plus 4. Since we have a perfect square trinomial on the left side, by design, we're going to factor it using the factoring trick I showed you. So I'm going to root the first and the last term and bring down the middle sign, okay? So what is the square root of x squared? The square root of x squared is x plus the square root of 4 is 2. Quantity square, 6 plus 4 is 10. Alright, so we're not doing the whole problem, we're just doing one step. So which one matches this option in question 60? We can clearly see that the correct answer is option B. So there you have it. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking here so you can get updates to the subsequent installments for this preparation package. And click like if you like this clip. Please post a comment to let me know what you think about this presentation. More clips, including access to this document, can be found on math.serve.com. Thanks again, and have a wonderful day.